exemplifier circuit with our RC here, which is made up of two 1 kilo ohm resistors, making it 2 kilo ohms, and our RE resistor here, which is just 1 kilo ohm resistor. And so what we're scoping right now is our VC versus our VM. So our V input is going to be in blue, and our VC is going to be up here, gain with a high gain and a voltage offset. And then we can also scope the VE simply by changing the wire from here to here. And when we do this, we see VE, which has no gain. However, there's a negative voltage offset. Yeah. And it should be noted that for this, there's no phase offset for either at the 10K for either VC or VE.
And they're the same gain.
Yes, they are the same gain. However, when we run the network at VE, we note that there is no gain, which should be correct. Oh, sorry, that's a blip. I'll just run a single. There's no gain until very high levels up in the megahertz ranges, and then there's no phase change. Phase stays at 0, so that means that there's never going to be lag in front of or behind. However, when we scope instead the VC, we know something interesting happening. We see the correct gain, as there is gain in the initial, but then as it approaches very, very high milliamps, the gain of the signal input goes up, which is surprising. However, that may be a flaw of the digital in at higher frequencies. And then the actual gain of the VC goes down. And this is accompanied by a phase shift from negative 180 degrees, which is basically 0, up to negative 120 degrees, which would put it like almost a third behind. So this is the first step, step A. We have 15 volts being fed in as the VCC into our diode setup.
Right. So here we have let's see, which one's R1? This 1K?
R1 and R2 are both here, a 22K ohm resistor and a 33K ohm resistor, which are being fed into B. One, the 22K ohm resistor is being fed into ground, while the 33K ohm is being fed into power. And then we also have coming out of E on the diode a 1K ohm resistor here, and we have going into the B terminal a 5K pot, which is currently tuned to 240 ohms, which is giving us a VC value of 13.2 and is giving us a VE value of 5, which is consistent.
Alright, this is part B, and it's a pretty similar circuit from A. We did switch over, so looking at B from here, the shared base, we switched over to two 22K pots, or resistors, and yeah, it's still got C going to the negative of this pot, and yeah, so our RL, excuse me, RL we have set at 768 ohms right now, so for VC we're getting 3.43 volts, and then we can switch it over to VE. And VE we're getting about 1.8 volts.